Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solid. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have got an isometric 3D projection of a solid in which the front view face, the top view face and the right hand side view face has been presented in a single 3D projection over there. Now with these isometric projections given, we are required to draw the front view, the top view and the right side views of this particular solid. Now in order to draw the orthographic projections of the solid, we need to evaluate the dimensions regarding the front view face, the top view face and the side view face which will be appearing in the orthographic projection. Now let us check out these dimensions from the isometric projection view. Now from the front view we can observe that the width of the solid, it is equal to 100 millimeter and the height of the solid is equal to 60 millimeter. So the front view face will be having the dimensions 100 millimeter by 60 millimeter, right? So these are the dimensions of the front view face. Then let us evaluate the top view face. So in the top view, once again the width of the solid will be required. So width of the solid is equal to 100 millimeter and besides width we need the information regarding the depth of the solid, and the depth of the solid happens to be 60 millimeter. So the dimensions of the top view of the solid will be 100 millimeter by 60 millimeter. Now the side view face will be having the dimensions 60 millimeter will be the depth of the solid and 60 millimeter will be the height of the solid. So the dimensions of the side view which will be drawn in the orthographic projections, it will be 60 millimeter by 60 millimeter. Now let us evaluate different faces that will be visible to us while we are looking at the solid from the front side, from the top side and from the right hand side over there. Now from the front side, if we are observing the solid, then there are three faces which will be observed by the observer. So the first face will be face which has been labeled as A. So this is going to be the face A. Now this face A happens to be parallel to the vertical plane. So the true shape of this face A will be available on the vertical plane in the front view. Similarly, faces B over here and face C, right? So these two faces, faces B and C, so they are also parallel to the vertical plane. So we are going to obtain the true shapes of these two faces, that is faces B and C, onto the vertical plane. So in the front view, we are going to obtain true shapes of the surface A, surface B and surface C over there. Now when we are going to look at the solid from the top, so we are going to have four surfaces which will be available with us. So the first surface which will be viewed from the top, this is the angular surface which is labeled as P. So in this case this is my surface P and this surface P is again parallel to the horizontal plane. So on HP the true shape of the surface P will be available. So same logic applies for the surface Q. So this is the surface Q, it is also parallel to HP. So the true shape of the surface Q will be viewed in the top view. Similarly, surfaces R and S, they are going to be rectangular faces, and since the surfaces R and surface S over here, they are both parallel to the horizontal plane. So the true shapes of the surfaces R and S, they will be obtained onto the horizontal plane. And when we are going to observe the solid from the right hand side, so the three surfaces, they will be visible. Surface 1, which is a stepped surface, you can check. This is a stepped surface and this surface also happens to be parallel to the profile plane. So the true shape of the surface 1 will be viewed onto the profile plane. Similarly, the surface 2, it is an angular surface and this surface also happens to be parallel to the profile plane. So again, true shape of the surface will be viewed onto the profile plane. And finally, this is the rectangular surface, surface 3, which will be viewed onto the profile plane. And again, true shape of the surface 3 will be observed on the profile plane, since the surface happens to be parallel to the profile plane, right? So let us start with construction of the orthographic projections of this particular solid. Now we are required to draw the front view, top view and the right hand side view of this particular solid. So the front view will be drawn above the XY line, top view will be drawn below the XY line, and since we are required to draw the right side view of the solid, so the right side view of the solid will be drawn onto the left hand side, right? So in the first angle projections, right side view will be observed onto the left hand side over there. Now let us start with the front view. So we have already worked out that the front view face will be having the dimension, that is width is equal to 100 millimeter and the height is equal to 60 millimeter. So we have marked this width corresponding to the front face above the XY line, and similarly the height equal to 60 millimeter has been marked over here, and we have obtained a rectangular surface which is going to contain the front face of this particular solid, right? So this is 100 millimeter width, 60 millimeter is the height of the front face. Now we have to move to the top view. So this width of the solid, it will be projected in the top view, because the top view also consists of the width of the solid and the depth of the solid, and we know that the depth of the solid happens to be 60 millimeter. This is 60 millimeter, right? This is the depth of the solid. So 100 millimeter is the width, 60 millimeter is the depth of the solid. So this is again another rectangular surface corresponding to the top face. This is equal to 100 millimeter by 60 millimeter. So this depth we have marked as 60 millimeter. Now the dimensions from the depth view, that is from the top view, they will be transferred onto the right hand side view using this transfer line. So this is our transfer line which will be used to transfer all the distances from the top view onto the right hand side view. So this way this depth has been transferred from the top view onto the right hand side view. So this dimension will be equal to 60 millimeter. So this is the depth of the solid, and in the right hand side view we are also going to get the height of the solid. So this height of the solid we have already drawn in the front view. So this projection we are going to obtain, so that now the rectangle corresponding to the right hand side view should be obtained. And since in this right hand side view the depth is equal to 60 millimeter and the height is also equal to 60, so this surface of the right hand side view, it becomes a square over there rather than a rectangle, right? So we have obtained the front view face, we have obtained the top view face, and we have also obtained the right hand side view face over there, right? So this information we have drawn over there. So this is no longer required. So we are going to erase this information. Now let us start with the construction of the front view of this particular solid. So if we are going to look at the solid from the right hand side, so we are going to observe that there are 3 steps over here. Each step is having height is equal to 20 millimeter. So first step is having the height equal to 20 millimeter. Second step is also having height equal to 20 millimeter. And the third step is also having the height equal to 20 millimeter. And another thing, here we have one smaller step on the left hand side which is having the height is equal to 10 millimeter. Okay, and another thing we should observe that the total width of the solid happens to be 100 millimeter, and out of this 100 millimeter, the first block that is on the right hand side, it is having the width is equal to 30 millimeter. So please check, this is the width equal to 30 millimeter, and this top web, it is having the dimension or the width equal to 20 millimeter. So this is 20, this width is equal to 30. So this remainder surface, that is the surface Q. So surface Q is having the width which is equal to 50 millimeter, right? So surface P on this side, it is going to have the width equal to 20. So this we have marked over here. So out of 100, on the left hand side, we have got the surface P. It is having the width equal to 20 millimeter. Then we have the surface Q. It is having the width equal to 50 millimeter. That also we have marked. And then we have the surface S over here, which is having the width equal to 30 millimeter. This also we have marked. And then we have drawn the vertical projector line so that these surfaces, they can be identified. And as I told you that on the surface P, so there is a step over here, that is after you move 20 millimeter from the left hand corner of the solid, as you move towards the right hand side, there will be a step which will be having the height is equal to 10 millimeter, right? So this height of the step is equal to 10. So this 10 millimeter also we have marked over here. So this is 20 millimeter corresponding to this surface, B, C and A surface over here. So this is 20, again you have 20 and again you have 20. So on the right hand side I have 3 steps, 20, 20 and 20. And please check, I have already marked this height of the solid is equal to 60 millimeter. And I have also marked these 3 dimensions at 20. So this dimension becomes a redundant dimension. So this only for the purpose of understanding this dimension has been drawn. So later on I am going to rub this off, because if this total is 60, this is 20, this is also 20. So automatically this dimension will be 20 millimeter over there, right? So this I will be taking out. That is why a different lighter color has been used over here. And you can check corresponding to the step which is available on the left hand side, that is as you move from surface P to surface Q, this height, this will be equal to 10 millimeter. So this I have marked over here. So with this information, now I can complete the front view of this particular solid. So in order to complete the front view, please check, this edge will be visible to the observer corresponding to the surface A. Now this is the width of surface P, which is equal to 20 millimeter. So this is 20 millimeter. Then there is a step as you move from surface P to surface Q, that is the transition from surface P to surface Q will be at a height of 10 millimeter over here. So as you move from surface P to surface Q, so surface Q as you move to, so there we have the height of 10 millimeter involved over there. And then you have to move 50 millimeter now. So 50 millimeter, it is the width of the surface Q. So this is the width of the surface Q over here. So this portion of the solid we have obtained over here in the orthographic projection. And what about this portion? In this portion I can observe corresponding to surface A, I have got the height of 20 millimeter. Again corresponding to surface B, I have got the height of 20 millimeter. Again corresponding to surface C, I have got a step height of 20 millimeter. So now I can join these. You can check, this is 20 millimeter, this is 20 millimeter and this is also 20 millimeter. But if I look at surface A, so surface A starting from this point, moving 10 millimeter down, then moving 50 millimeter towards right, and again now you are going to move 30 millimeter down. So here you are moving 30 millimeter because this was 10, so this is 10 plus 20. So as you move from surface A, that is surface Q to surface S, so as you are moving from surface Q to surface S, so you have to descend, you have to go down with a height of 30 millimeter. So this was height of 10, this is height of 30, which makes it 40, and then you move down by 20 millimeter, right? So then I'll be joining this point so that you obtain this bottommost corner of surface A over there. So as you move along A, move down 10 millimeter, then move right side 50 millimeter, move down 30 millimeter, and then move right 30 millimeter, and then move down by 20 millimeter. So this is your surface A. Then this is my surface B, which is a rectangle having dimensions, width is equal to 30, height is equal to 20. So this is the width equal to 30. This is height, it is equal to 20 millimeter. So this is 30 millimeter, this is 20 millimeter. Then I have my surface C over there. In the surface C, 50 millimeter by 10 millimeter, this is this narrow web over here. Then this surface, this is 20 millimeter height and 30 millimeter wide. So this is 30 millimeter wide. So I have to join this part also. So all the three surfaces A, B and C have been obtained. Now I can label these surfaces. So after doing the marking, this is the projection of the surface A onto the orthographic projection. These are the projections of surface B. Here I have got the projection of the surface C. And all these three surfaces A, B and C, they are represented as true shapes on the vertical plane because these three surfaces A, B and C, they happen to be parallel to the vertical plane. Now let's move on to the top view. As we look at the solid from the top view, so once again you can check this depth of the solid that is corresponding to the top surface P. This is equal to 20 millimeter. Then this depth of the solid corresponding to the surface R, this is also 20 millimeter. And this depth of the solid corresponding to the surface S, this is also 20. So 20 plus 20 plus 20 is equal to 60. So again, I have marked this total as 60 and 20 over here, 20 over here, and this has been marked with a lighter color. So only for the purpose of understanding, I have marked this dimension as 20, but later on this dimension and this dimension I am going to take off or I am going to remove over there, right? So that no redundancy should be there regarding dimensioning in the engineering drawing. Now, having drawn these projections through these points over here, now I will be able to obtain the three surfaces in the top view. So let us once again start with the construction of this block. So this outer block will be visible to me. You can check this outer block will be visible to me as I am looking at the solid from the top. So this outer block is visible, and then next I have got the surface P. So surface P is having, please check, width equal to 20 millimeter over here, and then if we talk about the depth, so this depth will be 20 millimeter and then this width will be 80 millimeter. So this is 80 millimeter over here, 80 by 20, and then over here I am going to get this width as 20 millimeter. So please check, it is this width of the left hand side web of this particular surface P. Left hand side web, it is 20 millimeter width and the depth will be up to 60 millimeter. And then you have to turn right, and as you turn right, so you will be ending here at a depth of 20 millimeter. So this is my depth of 20 millimeter. So surface P has been obtained. Now I have got the surface Q. So surface Q will be obtained once I am having this width of 50 millimeter. So this is the width of 50 millimeter and this depth should be 40 millimeter. So please check, this depth is 20, this is 20. So this makes it depth equal to 40 and this width is equal to 50. So this width I have marked over here as 50 millimeter. So this is my surface Q, and then this surface is surface R. This surface R is having dimensions, depth is equal to 20 and the width is equal to 30. So there is depth 20 and the width is 30. So same is with the surface S. You have the width equal to 30 millimeter and depth is equal to 20 millimeter. So all these surfaces, surface P, surface Q, surface R and surface S, all these four surfaces have been located, and we must remember that surface P, surface Q, surface R and surface S, all these four surfaces, they happen to be parallel to the horizontal plane. So their projection onto the horizontal plane in the top view will reveal the true shape of these four surfaces. Now let's move on to the right hand side view. So in order to obtain these projections, all these dimensions regarding depth, so they have been transferred onto the right hand side view, and whenever we are going to look at the solid from the right hand side, please check what we are able to see. Surface 1, So this is my surface 1 marked with yellow. You move 20 millimeter from the rear surface towards the front surface. Then move 20 millimeter down. Again move 20 millimeter towards the front surface. Again move 20 millimeter down. Again move 20 millimeter towards the front surface. And again move 20 millimeter down. So it is 20, 20, 20, 20, 20 and 20. So 3 steps are there, for which the depth is also 20 and the height is also equal to 20. So please check. This depth I have marked as 20. This is my height 20. Again the depth is 20. Again the height is 20. And again I have marked this depth as 20 and again this height is equal to 20. So all these depth and height I have marked as 20 over here. And then next is I have got the surface number 3. So the surface number 3 is this one. So whatever is the remaining portion after this, 10 millimeter down. So 10 millimeter down I have the surface 3 over here, right? So this vertical wall over here. So this is my surface 3 and these are the projections of surface 3 over here. Now I have to obtain the surface 2. So surface 2 is the remainder portion over here. Whatever is the remainder portion of this particular side view, this will be my surface number 2. So let me do the marking. So this is my surface 1, which corresponds to 3 steps which are visible from the right hand side. Each step is having width and height is equal to 20 millimeter. Then this is the remaining portion which is visible to me from the right hand side. So this is my surface 2 over here. And finally this surface, that is after 20 millimeter depth, so there is a depth of 40 millimeter and height, it is equal to 10 millimeter. This is my surface 3. So all the 3 surfaces, surface 1, surface 2 and surface 3, all these three surfaces, they happen to be parallel to the profile plane. So their projections as they are obtained on the profile plane in the right hand side view, they are also representing the true shapes of these 3 surfaces which have been marked with yellow color over there. So with this we have been able to obtain the orthographic projections of the solid, but we have got surplus dimensions over there, that is which we can afford to omit over there, and we can omit these special markings which we had done corresponding to the surfaces, so that we can have visualization and understanding of the orthographic views that have been obtained, right? So we have removed the markings from the projections. Now from the isometric projection also I have removed all these markings, and finally I am going to remove these dimensions over here. Now this is the final construction of the orthographic projections which have been obtained from the isometric view, which was showing us the front face and the top face and the side face of the solid in a single 3D view. Okay, so this was the procedure regarding the obtaining of the 3 front views, top view and the right hand side views from the isometric projection. So this is all for today. So we will be continuing with few more examples and illustrations regarding obtaining of orthographic projections from the isometric 3D projections of the objects. Thank you very much.